Hi, Vanakkam, Namaste, and welcome to Problem Solving for Effective Mathematics Teaching and Learning. I'm Dr. Jayanti from Experiential Math Solutions. In Lesson 1 and 2, we learned how to change repetitive questions to thought-provoking questions. In Lesson 3, we will learn how to introduce some of the mathematician's discoveries to young children. I mean, young means primary 6, secondary 1 and 2 children. Students may know many scientists, poets, but not many mathematicians' names. So this activity is to introduce some of the mathematicians and their discoveries to young children. Like Gauss. When Gauss was just 10 years old, his teacher asked the whole class, to find the sum of 1 to 100. The teacher thought this would keep the students engaged for some time. But Gauss, within few minutes, found the sum of 1 to 100. He had his own way of finding it. Teacher thought they have to calculate 1 plus 2 plus 3 plus, like mechanically they would calculate. But he got an ingenious method. 1 plus 100 is 101. 2 plus 99 is 101. And how many pairs of 101 we can find? So within minutes, he was able to find the answer. You can give these questions to your children or students and ask them to find 1 to 100. You can give them some hints. We are all not Gauss, so we can give them some hints, like few steps what I have given, and then they can follow the method and think of how to calculate 1 to 100, the sum of 1 to 100. Now, if we follow the Gauss method, then it's not very thought-provoking question. We just teach them a method and ask them to practice it. So the next activity should be something not following Gauss method, to think of their own method. How to find the sum of odd numbers from 1 to 99. Yes, they can still follow a Gauss method. That's why we have to specifically tell them not to use the same method. 1 plus 3 is equal to 4. This is my method. Students can think of their own method. So give them some time so that they can think of their own method. 1 plus 3 plus 5 is equal to 9. When they cannot think of any other method, you can give them hints. But do not give the final answer. Let them find the final answer. Then we can ask them how to find the sum of even numbers from 2 to 100. Again, let them work out. Now, after going through a couple of questions, they will think of their own method. So give them some time. Stand back. If they are stuck, then you can give them some hints. The next activity is how to find the average of first 50 odd numbers. The average of first 2 odd numbers, they should know what is the average. 1 plus 3 divided by 2, 2, they will find out. When I first gave this question to secondary 1 students, They all wrote all the odd numbers, 1 plus 3 plus 5 plus 7 plus first 50 odd numbers, and trying to add them all. But problem solving is mainly to find, they have to find the patterns in problem solving. So ask them to first find the average of first two odd numbers, average of first three odd numbers, and average of first four odd numbers. Using the pattern, they have to guess the average of first 50 odd numbers. Then they can find what is the average of 50 even numbers. But when they do even numbers, they have to find whether it's including 0 or not including 0. So you ask them to find both. Next, we will introduce another German mathematician, Goldbach. He found that every even integer could be expressed as a sum of two prime numbers. It's also found that every odd integer could be expressed as a sum of three prime numbers. Now, it is given that it's not a theorem. Theorem means there is a proof. Conjecture means it's not yet proved. So students will be surprised that it looks so simple, but still mathematicians have not yet proved this. You ask the students or your children to express some of the even numbers as the sum of two primes. For example, 12, 18, how about 26, 50, and ask them to check for more even numbers. If we are doing this in a classroom, you can ask the students to try different even numbers and then check with their neighbors whether it's true for all even numbers. Normally, students will choose all the big numbers, big even numbers, and try. Now we ask them whether it's true for 6, 4. How about 2? Actually, the conjecture is true for all even numbers greater than 2. So we don't tell them the conjecture in the beginning. We say partially what is given in the conjecture and then ask them to find out whether it's true for 2. Now we ask them to express odd numbers as a sum of three prime numbers. After students learn prime numbers, normally we ask them whether the given number is a prime number, something like that. But this doesn't have any, doesn't develop any thinking. So we can ask them to do something like this, which is in this method, students learn something about mathematicians and their conjectures or theorems, and also they remember the prime numbers. Now, odd numbers, they have to use only prime. They cannot say some other like 14 plus 3 because 14 is not a prime number. And ask them to check whether it works for all odd numbers and ask them to express it in more than one way. Some numbers can be expressed more than one way. So ask them to think of in any other using other numbers, can you express it? Lagrange is a French mathematician. He was the first to prove that every positive integer can be expressed as sum of 4 or fewer square numbers. This is known as Lagrange's 4-square theorem. For example, 37. is equal to 36 plus 1, that means 6 squared plus 1 squared. Again, after learning square numbers, this is a very good activity to try. But 37 also can be expressed as 16 plus 16 plus 1 plus 1. Remember, it should be expressed as a sum of 4 or fewer square numbers. Ask them to try with many positive number integers and ask them to try to express in more than one way. So in this lesson 3, we have introduced 3 mathematicians. Do you remember them? And next lesson I will come back with more mathematicians and their discoveries. With that, I say goodbye. This is Jayanti from Experiential Math Solutions. Please remember to subscribe our channel and stay tuned. Bye now.